Welcome back to the IU427 garage, everybody. Today we're working on the Coupe. I think where we left off last week is I was working on some of the wiring, and we also attacked the drive shaft safety loop. This week I'm working on some of the cooling system hoses. I think I'm going to jump into some more of the wiring and God only knows what else. So come right back. So as I said, we got the drive shaft safety loop finished up last week, and I think what I'm going to be working on this week is, one, getting this panel installed back in the car. So this is the panel that's going to go on the front side of this foot box. I'm going to diet out some of the wiring that we have here in our Holley harness, because some of this stuff is not going to be used on our engine. For instance, we're not going to be using a fuel pressure sensor. We're not going to be using a mass airflow sensor. There's quite a few things in this harness that we will not be using, and so therefore what I'm going to do is I'm going to cut them out of the harness, hang on to the connectors, so that if at some point down the road, you know, the owner changes his mind and he wants to go like with a supercharger and a standard intake system with a mass airflow sensor, all that stuff can be put back on. But as it stands now, I want to get all of the unnecessary connectors out of there, just so they're not, you know, dangling somewhere, you know, out of the way with tie wraps holding them up. I just as soon get them out of the harness so that we don't have to worry about finding a place to put them, honestly. And then I'm probably going to work on getting some of the holes drilled through our front upper tunnel piece, which is right here. So on you know, the Mark IVs, the Mark IIIs, and what have you before them, we would drill through the dash because, you know, that was really the only way to get through into the engine compartment. But on the Coupe here, and I'm assuming on the new Mark V, the best way to get those through is going to be near the top of this panel right here. So I'm going to drill a series of holes. I think I'm going to start with 3 of them, and I'm going to actually start over there on the passenger side, because I believe as we start adding things and coming this way, it's going to get really congested over on this side of the car, where all of the gauges and all of the air conditioning and heater tubing is going to go. I want to keep some of this open so that I have a pathway later on if I need to add something. So I want to make a couple of holes to get a couple of wire harnesses through, but at the same time, I just don't want to turn it into Swiss cheese and have extra holes that I have to fill later because I didn't use them all. So I'm gonna start with 3 access holes through that upper tunnel piece, and I'm gonna see if I have to add more later. What I did do between last week's video and this week's video is I did get this whole panel pre-fit. So I've got all of the clecos in the top across here, and I lined those holes up with the holes for the firewall, which is just below that panel, so that I just have one rivet going through in each one of those locations that will bond both this panel, the firewall panel, and the chassis all together. And then I made a series of holes down each side of the panel and got all those pre-drilled. Got some clecos in there now. I'm going to keep it removable for the time being. I probably will pull all these clecos out at the top and just put a couple in the sides to keep it in place while I do my work with the wiring. But I want to make that accessible for the time being, because otherwise I have to raise the car up, crawl underneath, do what I need to do in the transmission tunnel, and then lower the car back down to do my work on top. With it the way it is, I can just pull out a couple of Clecos, keep the car at a comfortable height, and just pull the panel loose without pulling it completely out, get access to the tunnel, run another wire or two if I have to. And so I think you see where I'm going with this, but so for right now, I'm just going to leave this panel in temporarily, and that way I'll be able to take the Clecos out, be able to pull everything loose, and have access to it. We did run into one problem in doing our coolant hoses, and I'll show you how far I got on the coolant hoses in just a second. But I started researching the wiring for the alternator, and I had known this from previous Coyote builds that the factory Ford ECU basically talks to the alternator. There's the way it was explained to me, it's a pulse that is output from the alternator, and it reports to the ECU. And without that pulse, the alternator does not get charged. Basically, the charge signal from the computer doesn't get activated. So I tried numerous ways to find a way around, a workaround for this. And I want to give credit where credit's due. The car owner went to an engine builder, I believe, down in his area, down in Huntington Beach, and the guy that he talked with was really nice about it because we didn't buy anything from him. But he said the Holley system allows you to do that pulse so that it can send out the signal to let the alternator charge the battery. But I'm not an engine tuner. And so we looked into some other options, and what we found is that by getting a one-wire alternator, which I'm not a fan of, so don't take it that way, but in this instance, it's just the easiest solution with the fewest questions moving forward. I don't have to worry about a pulse from the alternator to the ECU. I don't need to worry about the 12 volt from the ECU to send the charge command to the alternator. It's already pre-wired to just charge. It'll charge at idle at about, I think, 140 amps is what PowerMaster says, and up to 180 amps when it's at speed. So we've got an order in, and it should be here within the next few days. But what that has done is it will not allow me to finish up this 90 right here. So this 90 goes onto these two tubes right here to connect the lower output of the radiator to our water pump, because I need to actually move or remove this tube that is joined back in there to our radiator so that I can get access to get the alternator out. I have to loosen the serpentine belt at the tensioner. I have to remove the alternator, bolt the new one in, and then put everything back together. So while we saved ourselves a little bit of work as far as the wiring and all of the programming for the ECU portion of this by going with a one-wire alternator from PowerMaster, I created a little bit more work for myself in that I can't finish up the cooling hoses and tubes, and I actually have to remove some to get the alternator replaced. But this is the kind of thing that's going to happen. We're running an aftermarket ECU on this. I probably should have asked this question earlier, but until I got into the wiring, honestly, I just didn't think about it. So we've got the alternator on the way. It should be here within the next couple of days. Hell, it may be here tomorrow. But let me lower the car down. We'll take a look at how far I got on our cooling system and our clamps and hoses and everything else. And then we'll just kind of take it from there. We're going to start with some of the smaller hoses on the car, and we'll work our way around to the upper radiator hose because I'm really happy the way it turned out. The hoses I still cannot do are, one, that lower radiator tube slash hose that we just talked about, and then this one to the engine because I need access to the tensioner, and the tensioner is right back here. So I've left this hose loose. So this hose right here that is basically a like bypass hose. It's a hose that runs from the engine to our surge tank. So it runs off of this T right here, and then there is a tube in the bottom of our surge tank, and that basically moves most of the fluid that is in the surge tank. These two are just basically steam ports. They bleed off any air that might be trapped in either the radiator or the engine block. So this one comes up out of what on a small block will be the thermostat housing, and this is just a water housing. And this tube feeds over into our surge tank. Now you can see I've got the hose clamps on here, and these things are really cool. But there is a specific way they need to be installed. The Gates instructions say that they can be over the bead of the outlet. So the bead is right about here. But what they want is they want the majority of the contact surface on the hose over the fitting or the nipple, so that this portion where it's on the bead basically holds it in place, but the clamping is happening back here. And so we've done that both on this hose and this one up here. Now, it's deceiving because I went ahead and I fed the hose all the way down to the bottom, but the bead on this tube is way up here. It's right here. And it's the same thing here. The bead on this is right back here. So those are in place. You can see I put the protective sleeving that this hose came with over the hose. I just thought it would look more OEM. And as I stated in the last video, I really want this to look like, you know, it came from Ford this way. And like this is something that they would do on a concept car. So there's that steam port. We went ahead and we worked this front steam port to the radiator. Same thing. We ordered some 3/8 heater hose, and it's very important. You need to make sure that the hose you're ordering is for the application that you're using it for. So if I use 3/8 fuel line here, there would be an issue with the hose sealing. Now, you might be able to get it tight enough with a traditional hose clamp that it wouldn't leak. The problem is that most of that fuel hose is made differently. It almost has like a lining in it so that the ethanol doesn't eat the rubber of the hose. Coolant hoses and heater hoses aren't like that. They're just rubber hoses. And so because they're sealing in such a wide temperature range, you know, from ambient temperature all the way up past boiling, you want to make sure that the hose you're using is suited to what you're using it for. So we ordered Gates heater hose in a 3/8 size. And I think they call this their silver stripe. Somewhere there is a stripe on it. And that's how I believe they designate their heater hoses. But we just bought a 6-foot length. We've used about 4 feet of it here. I routed it as neatly as I could so that any steam, because that's what we're talking about here, we want any air to find its way up, and we don't want to create any pockets for it to settle in. So I tried to make this hose so it started low over here at the fitting, comes up at an angle along the side here, through a grommet, and I'll show you that from the other side, and then into our surge tank. And again, I got one of those Gates Power Grip clamps on there. And over here on this side, you can see where we have our black aluminum fitting coming out of the radiator, another one of the Gates clamps, and then I've got 2 cushion clips here. And you can see it all goes up at an angle, so any air that gets caught in here is going to work its way right back up to the surge tank. We've got a nice grommet in the back of the radiator tunnel for the tube to go through. That way we're not worried about any of this getting chafed or nicked or anything else. It's going to stay there for a good long time. And that hose is pretty much all complete. Over here for that passenger side heater hose, what I did is I actually took the bolt that runs through this fitting, because we bought these fittings to go into the block because we didn't receive them here at the shop when the engine showed up. So I pulled that fitting out, pulled the bolt out first, pulled the fitting out. I actually installed the clamp, the Power Grip hose clamp, on the bench. and it made it really easy to do because I could get full access all the way around. What I was worried about, if I did it on the car, I wouldn't be able to get in this backside really well to get it shrunk properly. Same thing, the clamp goes all the way down to the end of the hose. The bead of the fitting is right about here, and we've got that good and sealed up. I did take the crossover fuel line off, and that will have to go back in once we're all done. And I've got those two heater hoses all finished up to the other side. Lastly, for now anyways, is our upper radiator hose. So what I did here is we used the factory Ford connector on the end here. I had dug one of these out. It actually had a Ford hose still attached to it in my hose bin, and it was probably left over for another build. We sent this fitting along with the engine when the engine was dynoed, and this enabled the guys at the dyno to hook up their cooling lines to it. So they hooked up to here and down here, and they were able to have coolant flow through the engine. What I found though is they run straight water, and some of that water, that residual water, has been in the hoses that I had temporarily made as crossovers, and some of our fittings had already started to see rust. So I had to clean those up and put them back in. So that one over on that other side, I pulled all apart, cleaned up the rust that was in it, and then reinstalled it. We've got a power grip clamp on this radiator hose, and then what I did is I used this braiding that came with the original factory Ford hose, and I installed it over the hose that we bought. And if I remember, I'll put this hose number in the description box of the video. I don't know if anybody else is going to do this exact layout that we did. You could probably use the upper F-150 hose if you didn't have the surge tank here like we do. But in our case, I had to contend with the surge tank and route around it, and this hose just worked out perfectly. Then what I did to support it is, as much as I wanted to use the mineral lac clamp that I had bought, I ended up using one of these, it's like a zip tie standoff with a rivet hole in the back of it, and I attached that to the bottom of the chassis right there. And then I used one of my big 3-foot tie wraps, or zip ties, that we use out in the field for air conditioning, like tubing for commercial and residential air conditioning. They use these tie wraps to go around the outside insulation of the ducts, and to get them all tight and keep them in place. And so I had some of those here, and it's nice and heavy duty. You know, I had to cut off like 2.5 feet of it, but it works good here. And just the fact that it looks more OEM than it would have if I used the mineral lac clamp, and I would have made the mineral lac clamp look OEM by putting some heat shrink tubing around it. This just, I think, turned out better. It's very subdued. You don't see it unless you look for it. It holds the upper radiator hose perfectly, and it still keeps it off of the back of the radiator tunnel so that it's not hitting down here. And it came out really nice. We've got another power grip clamp right here. Again, the bead is right back here. And then we've got our powder coated black tubing that comes to our front 45-degree hose with 2 more power grip clamps, and that pretty much finishes off that upper hose. Like I said, I'm really happy with the way that turned out. I had a vision of that in my head, what I wanted it to look like, but sometimes no matter how hard you try, you can't get things to work out like you initially see them in your head. This one worked out exactly how I planned it, and I'm tickled. So I think that's where I'm going to leave it for today. I think I'm going to start on this panel right now and try to get this done today, but I just don't know if I'm going to have enough time to finish it. So we'll all find out together tomorrow what I actually did for the rest of the day. So I have what is a little bit of a rarity, and that is an entire Friday at the shop. But I spent most of the day filling parts orders and getting stuff packaged and ready to ship out. So last night what I did, it's actually 2 nights later than the last time I checked in with you guys. Last night what I did is I worked on getting the holes drilled in our upper tunnel piece. And I did a little bit of rethinking on the hole placement. Now, I wanted to make sure that I was far enough down from the top, right up in here, that the wires passing through weren't going to run right into the tube, this tube right here that continues all the way across. I also didn't want them running into either of the side tubes. One goes down here and then one goes up over here. So rather than starting at the side, which is what I was going to do, I was actually going to start over here. I actually started in the middle and I spaced my holes out. Now if you see, I've removed the heat and sound mat around the area where the grommet goes, because the grommets that come supplied with your Ron Francis harness, and that's what those are. We actually bought some extra ones, and so I have a couple laying around the shop. And I also had someone send me some, and that was very nice, and I want to thank them for sending me, I think they sent me 3. But I relieved the area where that grommet's going to sit, because it's only really made to go over the thickness of the 040 aluminum. You could probably get it to open up to 090 aluminum if you absolutely had to. But it would be snug. And so I relieve that area around the outside of where the grommets go through so that the grommets will sit flat. And then obviously the heat and sound mat continues on the rest of the panel. One note, and I don't know if it's just me and I got spoiled with the fat mat. This material is much more like gooey. It's hard to remove, which is a good thing. But in the areas around where I was removing the material, I was kind of scraping it with the tip of a beat up screwdriver, and it wants to stick to everything. It wants to stick to your hands. It wants to stick to the panel. That's good. My only problem, like, going forward from here is that's in a climate controlled area. The shop is heated and air conditioned, and I don't know how this stuff's going to react when it gets hot. Is it going to get like super gooey and want to turn to liquid? So I don't know that I'd use the kill mat again. We have it. We're going to use it, but I'm going to keep up with the car owner once his car gets on the road and see if there's any issues with this. I'm sure if there are, he'll let me know. But so I got those 3 holes drilled in the upper part of the tunnel there, and I'm going to leave it at just those 3 right now, because if I figured right, I'm going to use one for all of the Holley stuff. I'm going to use one for the power wires going through for both the chassis harness and what else? There was something else. Maybe the Holley power wires, because I think there's 3 Holley power wires that go through there, the hot, the ground, and then the power for the fuel pump. And so I might run those through with the power for the main chassis harness as well. And then the last one's going to get what's going to the rear harness, and then I'll send the gauge harness through that same grommet out to the engine bay. I think I'm going to revisit the alternator supply wire. Basically, the alternator supply wire is just a loop. It goes from where the starter is and loops around through the harness over to the alternator. The one that's included in the Ron Francis harness is either 10 gauge or 8 gauge. I have to check it. I think I'm going to up that wire gauge, probably to a number 4, possibly a number 2, only because I'm a little worried that the manufacturer of the alternator, and it arrived yesterday. The car owner actually sent me a message, I think about 2 o'clock or so, and asked me if it had been delivered, but I was still at work. And so I just quickly looked at the cameras around the shop here. I saw that it was here, and I said, yeah, it's here. You know, I'll be there in a half hour or so. So, you know, it's good. We'll get it when we get there. But it's here. And what we ordered is this Power Master one-wire alternator. So I'll probably be installing this tomorrow, but they include, the box is kind of beat up. They didn't pack it in any other box than the actual box for the alternator. And it looks like the box went through a war in the time it took to get here. But anyways, they give you instructions for hooking the one-wire alternator up. And then on the back, they also give you a wire gauge size for not only the ampacity, but for the length of the actual cable. I'm going to go by this chart, and we're going to find out exactly what size wire that we need to run, and that's what I'm going to run. I'm going to strip the one that's in there out, and we're going to run a bigger wire just so that there's no issues later on with this thing, you know, overcharging or putting too much amperage through that cable that came with the Ron Francis chassis harness. Next day, everybody, I got the alternator installed. So I took the original Ford alternator out and I put the Power Master alternator in. Not a lot to show. It looks the same, except now it is got a black case on it. So no big deal. Someone did point out that on the label here, someone spelled gauge wrong. I hadn't even noticed that when we installed it, but nonetheless, it's installed. And what I'm working on now is replacing the alternator feed wire. So it's the wire that goes from either the battery post, or in our case, it's going to be the starter. And what I did here is I used a 5/16 bolt through there to hold all this stuff together because I didn't want it to be hard to line up later. So there's not a whole lot of flexibility in a lot of these bigger cables. So the closer I make it to perfect on this side, the better. And then I'm working on this side over here. I've got a 5/16 eyelet on this side as well because that's what the alternator takes. And then I've taken the trigger wire. This comes from the ignition switch. Now, if you're using a stock Ford alternator, keep this in mind. Most of the 3G and up alternators, so that would be 3G, 4G, and 5G alternators, all require a resistor in line in order to make them work properly. So, for instance, on a 3G, 4G, I believe it's a 470 ohm resistor. On a 5G, I believe it is a 510 ohm resistor. So you want to make sure that you've got a resistor in line for this so that it feeds the alternator the right signal to turn it on and off. We don't need it, so I've just taken it and bent it back over itself and put some heat shrink tubing over it. So it's going to stay just like this. And then I've got to put the split loom back on for this side and the split loom back on for that side, which I just stepped on because it's on the floor. What I did is I took the existing wire out, so that's this one here. Got it right there. See if I can do this with one hand. So that's the wire we pulled out. You can see everywhere where the masking tape was. That's what Ron Francis does to keep all the wires kind of contained in the split loom. I did very much the same thing, but I used that for my measurement when I cut my wire. I have a bunch of bulk battery cable here. I didn't have any number 6 wire because I was thinking about using that, but when I spec'd out the size wire that they say they want for a 180 amp alternator, I ended up at number 4 anyway. So I've got a number 4 battery cable basically that I've put eyelets on, 5/16 on either side, and then put heat shrinking on the end, and then you can see I've taped it in about the same location, but I've used red masking tape because that's what I have. In each of these locations, here it just makes a loop, so it's coming from the starter motor around, and then it'll go down to the alternator. So it's just a simple loop here. A lot of times when we're doing the Roadsters, the Mark IVs anyways, we'll put an isolated battery tap or a stud on the firewall right back here. There's really no good place for it on this car, and I thought it would just be another added thing to look at. And as clean as we're trying to make this engine bay, I didn't think we needed it. So we're going to tie everything down at the battery post, not the battery post. We're going to tie everything down at the starter post, just like is outlined in your Ron Francis wiring guide, and it's going to be fine. So our main battery feed is going to feed directly to that starter post, and then all of these wires are going to feed into the chassis harness and then over to the alternator. The only other wires that we're going to have that are going to go directly to the battery are going to be those wires that come from the Holley Dominator ECU. And it says right in the instructions that they must land on the battery. And there's two reasons for that. The battery acts as a kind of a filter for all of the EMI interference that may be generated in the engine and everywhere else. And so it acts as this giant magnet to suck all of that EMI, the frequencies out of the wiring. And it also acts as like a shock absorber, so that if there's any spikes or anything in the electrical system while the car is running, hopefully the battery will absorb those spikes and not transmit it directly to the ECU and burn it out. That's the explanation that I've been given directly from Holley, and it's kind of outlined in their installation guide. So we're going to run those directly to the battery. Those are the only other cables that are going to run all the way to the front of the car. The rest of them are pretty much just at the engine. So I'm going to finish this up, and then I'll probably catch up with you tomorrow, and hopefully, I don't know, hopefully I'll be feeding these wires through the upper part of that tunnel and kind of getting them placed in where they go. That is where I'm going to leave it this week, everybody. I have dived head first into wiring. So if you look here, I've got the entire Holley harness out. I've got some of the wires into the dash and through the front of the upper tunnel. But that'll be next week's video. If you're enjoying the content here, as always, please do the like, the share, the subscribe, all that kind of stuff. We'll see you next time. Have a great day.